On the Giza Plateau, in the heart of the Great Pyramid, there is a chamber that should not exist in the way most people imagine it. It sits deep inside the structure, directly above the room known as the King's Chamber. It is empty. No inscription, no treasure, no body. Just a stack of massive limestone beams, each weighing many tons, positioned with a precision that still draws engineers back to study it more than 2 centuries after it was first entered. This space is known today as the Grand Gallery's neighbor in a sense, but more precisely, it belongs to a set of chambers above the King's Chamber called the relieving chambers, or sometimes the chambers of construction. The lowest of them, discovered in 1765 by Nathaniel Davison, bears his name. Above it lie 4 more, discovered decades later by a British explorer named Richard William Howard Vyse, who in 1837 used gunpowder to blast his way upward through the solid masonry, searching for hidden spaces. What he found were 4 additional low chambers, each roofed with enormous granite slabs, stacked one above the other, and on the walls of some of them, hurried marks in red ochre paint. Quarry marks. Workers' notations. Names of work gangs, and in at least one case, a cartouche that appears to name a pharaoh. This is the story most people never hear in full, because the popular version of the Great Pyramid skips past the unglamorous truth and reaches straight for mystery. But the real story, the one built on physical evidence, measurement, and more than 2 centuries of dedicated study, is strange enough on its own. It does not need embellishment. It only needs to be told carefully. Let's start with what we actually know, because the foundation of any honest account has to be the evidence, not the speculation built on top of it. The Great Pyramid of Giza was built during the reign of the pharaoh Khufu, who ruled during Egypt's 4th dynasty, roughly 2560 BCE, give or take a few decades depending on which chronology you favor. We know this not from guesswork but from multiple independent lines of evidence. Those red ochre quarry marks found inside the relieving chambers include a cartouche reading Khufu, painted by the work crews themselves as they hauled the stones into place, never expecting anyone to see it again. We have the diary of a real official named Mirror, discovered in 2013 at Wadi al-Jarf on the Red Sea coast, written on papyrus, describing in his own words the transport of limestone blocks by boat from the quarries at Tura to the construction site at Giza. We have the workers' village at Giza itself, excavated extensively by archaeologist Mark Lehner and his team beginning in the 1980s, revealing bakeries capable of producing thousands of loaves of bread a day, breweries, dormitories, and the bones of cattle and sheep consumed in quantities suggesting the laborers were fed well, not starved. We have their cemetery, where the workers who died during construction were buried with the same care given to more prominent Egyptians, some with inscriptions honoring their labor, a detail that quietly overturned the old idea that slaves built the pyramid. The people who built the Great Pyramid were, by the best current evidence, a rotating labor force of Egyptian citizens, conscripted for a period of service, fed, housed, and organized on a scale that required extraordinary administrative sophistication, whatever their tools may or may not have been. None of that answers the question everyone actually wants answered, which is how. How does a civilization without iron tools, without the wheel in the sense of cartwheels for hauling, without any technology we would recognize as heavy machinery, manage to move over 2 million blocks of stone, some weighing more than 2.5 tons, some in the case of the granite beams above the King's Chamber weighing between 25 and 80 tons each, and assemble them into a structure with a level of precision that modern construction crews, working with laser levels and satellite positioning, still find difficult to casually replicate. The precision is not exaggerated. It is documented, measured, and remeasured by serious researchers going back well over a century. The British engineer Flinders Petrie surveyed the pyramid in the 1880s with instruments he built himself, and his measurements, refined slightly by later surveys, still stand as a benchmark. The base of the pyramid, a footprint of roughly 13 acres, is level to within about 2 centimeters across its entire perimeter. The 4 sides are oriented to true north, south, east, and west with an average error of only about 3 arc minutes, a 20th of a single degree, achieved without a magnetic compass, in an era when the compass as we know it would not exist for thousands of years. The 4 corners form angles close enough to a perfect 90 degrees that the total error across the whole base amounts to a matter of minutes of arc. These are not folk legends. They are numbers you can find in peer-reviewed surveys and academic papers on Egyptian archaeology. How was this done without modern tools? Archaeologists and engineers who have actually tried to reconstruct the methods, rather than simply marvel at the results, have proposed workable answers, and it is worth taking them seriously before reaching for anything more exotic. For leveling the base, the builders likely used a network of trenches filled with water, since water finds its own level regardless of terrain, combined with sight lines and simple surveying tools. For achieving true north alignment without a compass, the most widely supported theory involves what is called the simultaneous transit method, tracking a pair of stars as they rose and set on either side of the pole, and bisecting the angle between their positions to find true north with remarkable accuracy, a technique that requires nothing more advanced than patience, clear nights, and a working understanding of the sky, which the ancient Egyptians certainly had. For moving the stones, we have direct physical evidence, not speculation. In 2018, a team led by French Egyptologist Pierre Taulet and colleagues published detailed findings from Hatnub, an alabaster quarry southeast of Giza, revealing a ramp system flanked by staircases with post holes, apparently used with ropes and sleds to haul heavy stone blocks up steep gradients using a kind of leverage and counterweight system historians hadn't fully appreciated before. Wall paintings from the tomb of Jehudi-Hotep, from a later period but showing continuity of method, depict a single large statue being dragged on a sled by dozens of men, with a person standing on the sled itself, pouring water in front of the runners. A detail that puzzled researchers until a team of physicists at the University of Amsterdam demonstrated experimentally in 2014 that wetting sand ahead of a sled can cut friction by as much as half, making the load dramatically easier to pull. None of this is guesswork born of desperation to defend a boring answer. It is the product of decades of experimental archaeology, in which researchers physically test hypotheses rather than simply asserting them. And yet, even with all of that, there remain aspects of the Great Pyramid that continue to generate real scientific curiosity, not because mainstream researchers doubt it was built by 4th dynasty Egyptians, but because there is still more to learn about exactly how, and what the internal structure is even fully composed of. This is where the story gets genuinely exciting, because unlike a lot of pyramid content online, this part isn't speculation. It's ongoing, real, peer-reviewed science. In 2015, an international collaboration called the Scan Pyramids Project began using a technique called muon tomography to look inside the Great Pyramid without drilling or disturbing a single stone. Muons are subatomic particles, produced when cosmic rays strike the upper atmosphere, that rain down on the Earth's surface constantly and can pass through solid rock, losing energy as they go. By placing detectors inside and around the pyramid's known chambers and measuring how many muons pass through versus how many are absorbed, researchers can effectively build an X-ray-like image of the stone's interior density, revealing voids that would otherwise be completely invisible. It's the same basic principle used to image volcanoes and, at one point, was even used to peer inside a reactor at the damaged Fukushima nuclear plant. In 2017, the Scan Pyramids team, publishing their results in the journal Nature, one of the most rigorously peer-reviewed scientific journals in the world, announced the discovery of a previously unknown void above the Grand Gallery, at least 30 meters long, a space that had never been recorded, mapped, or entered in the entire history of pyramid exploration. They called it the Big Void. Its exact purpose remains unknown. It could be a construction gap, a deliberate architectural feature to relieve structural stress, or something else entirely. Researchers have not claimed it is a hidden chamber full of secrets, because the honest, responsible position is that we simply do not know yet, and further scans, including work published in later years using more refined muon detectors and even attempts to insert small cameras through tiny existing gaps, are ongoing. This is, in many ways, a far more interesting story than the fabricated AI discovers ancient secrets narratives that circulate online, because it is real. Scientists really did build sensitive particle detectors, deploy them inside a 4,500-year-old monument, and use fundamental physics to see through solid stone. That happened. It is documented, published, and repeatable. No one needed to invent a mysterious algorithm or a secretive research team whispering about golden ratios to make the Great Pyramid feel astonishing, because it already is. Now, It would be dishonest to pretend that mathematical curiosities in the pyramid's dimensions are pure invention. Certain numerical relationships genuinely do appear when you divide the pyramid's measurements against each other. If you take the perimeter of the base and divide it by twice the height, you get a number very close to pi. This has fascinated writers and researchers for well over a century, since at least the work of the pyramidologist Charles Piazzi Smith in the 1860s. But here is where responsible treatment of the topic matters. Mainstream Egyptologists and mathematicians, including Petrie himself, have long pointed out that this relationship likely emerges naturally from the ancient Egyptian method of measuring the pyramid's slope using what's called a sect, a ratio expressed in terms of horizontal displacement per vertical cubit, similar to how a modern roofer expresses a roof's pitch. If you build a pyramid using a sect of 5.5 palms per cubit, a completely ordinary practical measurement recorded in surviving Egyptian mathematical papyri like the Rhind mathematical papyrus, you get a slope that produces a height-to-perimeter relationship approximating pi as an incidental consequence, not because anyone was deliberately encoding the mathematical constant into the architecture. This isn't a dismissive debunking so much as it is, honestly, just as interesting as the mystical version, because it means the ancient Egyptians had a practical, working system of applied geometry sophisticated enough to produce this relationship as a byproduct of ordinary craft. The sect system appears repeatedly across multiple pyramids at different sites, with different resulting angles, which is itself strong evidence that Egyptian builders were working from a standardized mathematical toolkit passed down through a tradition of trained scribes and architects, not reaching for universal constants for symbolic reasons. The golden ratio claims are on shakier ground. Multiple careful reanalyses of the pyramid's measurements, done by mathematicians specifically checking these claims, have found that alleged phi relationships in the Great Pyramid tend to fall apart under scrutiny once you use the actual surveyed dimensions rather than rounded or convenient approximations, and depend heavily on which specific measurements a given researcher chooses to compare. This matters, because with a structure containing dozens of measurable lines, angles, and ratios, it becomes mathematically inevitable that some combination of them will approximate some famous constant purely by chance. This is a well-known phenomenon in the study of numerology-adjacent claims generally, sometimes referred to informally as the problem of overdetermination, where enough numbers give you enough opportunities to find a match to almost anything if you're willing to search hard enough and discard the combinations that don't work. Serious researchers who study the pyramid's mathematics tend to treat the pi relationship as a plausible and explicable byproduct of construction method, and treat many of the more elaborate golden ratio and ancient calendar encoded in stone claims with real skepticism, not because they're closed-minded, but because those claims generally don't survive rigorous, transparent recalculation using precise, published measurements. What about the claims of a vast network of ancient monuments aligned across the globe? Pyramids in Egypt supposedly pointing in a straight line towards sites in South America or the Fertile Crescent. This is where the line between genuine archaeology and speculative pseudo-archaeology becomes sharpest, and it's worth explaining why, because the distinction actually matters and isn't just academic gatekeeping. Any 2 points on the surface of a sphere can be connected by a line, and if you're willing to search the entire globe for ancient or notable sites, you will always find some that happen to sit near a great circle drawn from your starting point, purely because the Earth is covered in thousands of archaeological sites and ancient monuments spanning tens of thousands of years, giving enormous room for coincidental alignment. This is not a controversial statement among mathematicians or archaeologists. It has been demonstrated repeatedly that you can draw a significant alignment connecting almost any famous ancient site to almost any other famous ancient site if you're not constrained by requiring the civilizations in question to have had any plausible means of measuring the Earth's curvature, communicating across oceans, or agreeing on a shared purpose. The people who built Göbekli Tepe in what is now southeastern Turkey, one of the oldest known monumental sites in the world, dating back roughly 11,500 years, and the people who built the Great Pyramid, separated by more than 6,000 years and thousands of miles, left no evidence whatsoever of contact, shared symbolism, shared building technique, or shared language. Claiming they were part of a single coordinated network requires not just finding a numerical alignment, but explaining away the complete absence of any other kind of connection, cultural, genetic, linguistic, or material, which the alignment theories generally do not attempt to do, because there isn't an answer that holds up. The idea of a lost, advanced civilization predating all known history, one that supposedly seeded its knowledge into scattered monuments before some ancient cataclysm wiped it out, is an old idea, older than most people realize. It traces back partly to 19th-century writers like Ignatius Donnelly, whose 1882 book on the lost continent of Atlantis popularized many of the tropes still circulating today, and it has been revived periodically ever since, most recently in popular documentary series built around the same basic claims. Professional archaeologists have engaged with these claims directly and at length, not dismissed them out of hand, and the consistent finding, across excavated sites on every inhabited continent, is an enormous, continuous, traceable record of technological and architectural development, exactly the kind of gradual accumulation of skill you'd expect from independent human societies solving similar engineering problems with the materials available to them, rather than a single vanished master. Civilization. Stone masonry techniques that look superficially similar across different cultures, tight joints, megalithic blocks, precise leveling, tend on close inspection to use entirely different methods suited to entirely different local stone types and entirely different tools, which is itself evidence against a shared origin and evidence for independent invention, since human beings facing similar physical problems, moving heavy objects, building stable structures, tend to converge on similar solutions without needing to have met each other. None of this makes the Great Pyramid less extraordinary. If anything, understanding what we actually know makes it more impressive, not less, because it means a Bronze Age society without cranes, without pulleys as far as we can tell, without any written record we've found that fully explains their surveying method, achieved a level of precision that took modern engineering firms centuries of accumulated science to casually match on flat, easy terrain with iron and diesel and satellites. The honest mystery isn't who built it, we know that, or roughly when, we know that too, but the exact organizational and engineering choreography of it, the fine details of how a labor force of, by most estimates, somewhere between 20 and 40,000 rotating workers at any given time was fed, housed, trained, and coordinated well enough to hit these tolerances using tools we can hold in our hands and fully understand. That is not a small mystery. It is, if anything, a more human one, because it doesn't require inventing a vanished super-civilization. It requires us to take seriously just how capable ordinary human beings, organized well, motivated, and given enough time, actually are. There is also a real and ongoing scientific mystery embedded in the relieving chambers themselves, the ones we started with, and it doesn't need embellishment either. The purpose of those 5 stacked chambers above the king's chamber has been debated by Egyptologists for close to 2 centuries. The most widely accepted explanation is structural, that the chambers exist to redistribute the enormous weight of the pyramid's mass above the king's chamber's flat granite ceiling, preventing it from cracking under the load, a kind of ancient load-bearing engineering solution using a stepped series of relieving arches. This makes sense, and it appears to work, since the king's chamber's ceiling has survived intact for over 4,000 years despite the almost inconceivable weight of stone pressing down from above. But it doesn't fully explain some of the finer details, like why the workers took the time to smooth and finish only the underside of the lowest chamber's beams while leaving the upper chamber's stones comparatively rough, or why the specific proportions and gable roof design of the topmost chamber, called Campbell's chamber, take the particular form they do. These are the kinds of open questions genuine Egyptologists actually discuss in academic papers, small, specific, evidence-based puzzles, rather than sweeping claims about lost civilizations, and they're honestly more satisfying to dig into, because they're questions we can actually make progress on with more research, more scanning, more careful study, rather than questions built on unfalsifiable claims. So if the question is who built the Great Pyramid, the answer, backed by physical inscriptions, administrative records, worker cemeteries, quarry logs, and a papyrus diary written by a man who was there, is the ancient Egyptians of the 4th dynasty, under Khufu, using an extraordinary combination of applied mathematics, organizational skill, seasonal labor, and physical ingenuity that modern experimental archaeology has done a genuinely impressive job of reconstructing piece by piece. If the question is how they achieved such staggering precision without modern tools, the honest answer is a combination of things we understand reasonably well: water leveling, stellar surveying, wetted sand and leverage-based hauling, and things we're still actively researching. like the exact logistics of moving the largest granite beams and the full purpose of internal structures like the relieving chambers and the newly discovered Big Void. And if the question is whether the pyramid encodes secret warnings from a vanished global civilization, the honest answer is that decades of rigorous archaeological, mathematical, and physical investigation have not found credible evidence for that claim, and the numerical coincidences that seem to support it tend to dissolve under careful, transparent recalculation. What's left, once you set aside the manufactured mystery, is something better anyway. A 4,500-year-old structure, built by people whose names we've found scrawled in red paint on hidden stones, whose bread ovens and cattle bones and workers' tombs we've excavated, whose engineering choices archaeologists and physicists are still, right now, in the present tense, using cosmic ray particle detectors to investigate. The Great Pyramid does not need an invented answer. It has been quietly and patiently giving up real ones for 200 years, to anyone willing to look closely enough, and it likely still has more to tell us, through instruments that don't need to imagine an ancient message in order to find something remarkable inside the stone.